wings, not anchors. Building tools for the cloud. So a little bit about me. My name is Jacob Mather. I'm a senior software engineer at Kickside. They're a San Francisco-based game company that primarily builds mobile games.
Is there one claim to fame in there that we would all know? Or?
Probably not. I hadn't heard of any of their games, but if you like their games, then you know about them. And if you haven't heard about them, check them out. If you like StarCraft, you would really like a lot of the stuff they make. It's like StarCraft mixed with World of Warcraft. So you get massive multi online players with the StarCraft type mechanic instead of like dungeon hunting.
Okay.
I've heard of Vega Conflict.
Yeah. Vega Conflict and Battle Pirates are pretty roughly equivalent as far as like gameplay itself. Vega Conflict looks a bit nicer though. I'm also a co-organizer at the San Francisco PHP user group. And I call myself a community evangelist. I'm very, very big on community involvement and participation. You guys coming to this conference is a very good step in that. Being involved in the community gives you access to resources and knowledge that you would not have otherwise. It's one thing to use a project off of GitHub and have a bug with it and just give up or get frustrated with it. But if you go to a conference and you meet the guy who made the tool, it's really easy to just ping them on Twitter or on GitHub and say, hey, this thing is broken. How can I fix it? How can I help you fix it? And so getting those connections in place gives you access to get answers much quicker. You know exactly who to go talk to. You know exactly, you learn about different technologies and different pieces that your friends are working on. And it really helps round out your ability to just run and make solutions happen. If you have any interest in following up with me afterwards, I blog on jmather.com, and I sometimes tweet on Twitter at bjmather. If somebody's sitting on jmather, they won't let me, they haven't been on it for like 5 years. They won't let me buy it from them, nothing. It drives me crazy. So let's get to know each other a little bit more first. I like this game. Have you ever? I saw this picture and I just had to throw it in the slides. I'm digging through. Wow. Right? It's subtle. It's a little joke. It's subtle. But something went wrong somewhere. There's a check missed very clearly. Raise your hand if you've ever developed software as your primary role. Cool. How about manage servers as your primary role? We have any testers in the house? Primary role of testing, following up on that stuff? Okay. Who has executed RMRF/ on a server? On a production server? That's fun. The feeling in the pit of your stomach when you realize what you've done, you can't hit Control-C fast enough. You just can't. And if you don't, all your tools just go away. There's really like almost nothing you can do if you don't do it fast enough. It's very frustrating. And all of this reminded me of a quote. Let's make better mistakes tomorrow. Think about that a lot, because we always make mistakes. We always screw up. We always do things wrong. It's all about figuring out why you made the mistake and making corrections to not do it again. I figured I'd do a little bit on my background, because I present myself as a software engineer, and then I'm talking about DevOps and QA and their requirements and their needs. And so I'm going to give you a bit of a background for how I would know about these things. And it really all starts way back when. I was 16 and playing with little things here and there, just trying to figure stuff out. Playing with QBasic, playing with the apes throwing bananas, when you're way little, checking out books in grade school, learning QBasic, all that fun stuff. And then I got into high school and they hired me as a network helper over the summer, and they started. I started picking up Linux and realized that I wanted to play games with my friends down the street. And so we dug ourselves a Cat5 cable tunnel, and we ran our own network between our houses. And then I figured out how to share dial-up networking with Linux to give us both internet access. And just like really crazy with that sort of thing. And so then I branched out into like network software. I started learning Java because I realized that I kind of like Linux and kind of like to play with it on the desktop, and I kind of switched back and forth a little bit. So I wanted to write software that I could use wherever I was. After that, I kind of really branched out because I found PHP and I found web development and realized that I could write stuff that showed up in the browser that ran everywhere. Like I didn't have to worry about the details, I could just make it work. And so eventually, I got kind of bored with running a hosting company and everything. I didn't know enough about running a business then. So I went, and my daughter was on the way. So I got a job as a solo developer, state of Michigan. Continued the same sort of hosting client work I did for multiple people just for them. So it kind of helped to refine like working in a larger organization. And then I went from there to working at Mashry, and Mashry is bought by Intel, and now I work at Pixai, working in teams and seeing how all of the interactions between the different departments come into play when you're just trying to do simple things like develop some software. And now that we know a little more about each other, what is DevOps? I kind of see DevOps as the gateway that connects an engineering organization. Not that, no, not that one. That one, that's much better. That's a much better gateway. And it's kind of it's a squishy thing. We were talking about it before earlier. It's squishy because you could ask 10 people what DevOps is and get 10 different answers, and none of them could be wrong, or none of them could be right. And so if you look at it kind of like pulled back, DevOps just kind of connects QA, development, and operations. Because DevOps will, put together the Jenkins server that runs the tests. So the development team releases their code to DevOps to run the quality assurance tests on them, and at that point, if they pass, they're handed off to operations. Most people usually show this as a Venn diagram, but the center is very, very small. And I think if we really, really look at it and look at the way organizations could really function well, they look a little bit more like this. And it's just, there's so much overlap, so many places that each team can help each other. If they just pay attention and communicate well, you can find those spots. But then when you look at it like this, if you are labeled as a DevOps engineer, you kind of have 3 bosses. And the Bobs don't like 3 bosses. And eventually you're going to have priority struggles, and if you don't have strong management, that's going to be you. You're going to be very sad, very frustrated. And so let's look at giving you guys some ways to approach things that will help ease the pain. So let's look at specifically building useful tools. And the way I like to talk about this, actually, is business management theory, which is an interesting sort of approach from everybody I've talked to. There's this theory called jobs to be done. And it's the theory that people hire things, like products or tools or things or watching TV, to complete a job that occurs in the course of their life. Like, when you go to Steak and Shake in the morning to get a shake, you're not trying to buy a shake. You're trying to have breakfast. You're not clearly picking a great breakfast as far as health is concerned, but maybe you have different requirements. Maybe you commute a lot. Maybe you want something to drink that's going to keep you entertained. A shake would do that pretty well. And so, if you think about things in terms of the job to be done, then what you need to do is the tools you build. You need to orient to specific tasks that you can help your users complete. And then the last part you have to do is you have to build this tool that performs a specific task that works in the way that the users of that tool are already accustomed to working. Otherwise, they're not going to use it, unless it's way better than what they're used to.
Or required somehow.
Yes. You can always steer people into using your code, sure. That is a valid strategy. It's not a long-term strategy, but it's a valid one. Now, the problem, well, maybe not the problem, but the hard part about all of this is that in order to do this, you have to really actually understand the job that needs to be done. But to understand the job, you need to understand what the user performing it is doing. You need to understand what they're trying to accomplish and why. Because sometimes, and you learn this throughout the course of like client work and freelancing, maybe sometimes it's the wrong word. Often, when people ask you for things, they don't actually know what they're asking for. They know a specific piece of pain that they would like you to solve. But they don't see the more abstract piece of it. But you guys are in a great spot to see that pain because you're not so connected. You can step back and you can look at what they're actually doing in the context of their work and help them to break down what they actually need a tool to help them with. The best way to begin to understand someone is to practice empathy. Now, I'm not asking you to get like all mushy with your coworkers. Just put yourself in their shoes. Ask yourself, what do test engineers want? What do they need out of the system? Your QA department wants to ensure that all of your code is being executed as expected. They want to ensure all the intended use cases are covered in their tests. They also want to do some security testing and ensure that all unintended and negative cases are also covered. Just to make sure that people aren't going to try and find crazy ways to break your code. They also need to know that the test results they get back from the system are reliable. If you can't rely on the results of the test, there's really not any point in running them. And they also need to keep track of all this data over a long period of time so that you can actually see the changes to the code, the behavior, and the results. And that's how operations and development and QA can realize how effective their changes within their priorities in their organizations have affected the quality of the code that's created at the end. So how can DevOps help QA? How can they help their testing engineers? Make sure you get those unit tests, integration tests, and functional tests automated as quickly as possible. As soon as possible, as easily as possible. Do everything you can to make sure that they're simple to run. If they can just run automatically when you check it in, that's awesome. If they need to be triggered manually, fine. But just have a way to make sure that they're ran continuously over and over to make sure that the code stays good. Record the code coverage metrics for all forms of testing. And publish them individually as well as combined. This is interesting in that usually when you see code coverage numbers, you'll see them specifically tied to just unit tests. Occasionally you'll find code coverage for functional tests. It's a different kind of beast to handle though, and it takes a lot of integrated tooling. And every once in a while, you'll come across a group that's managed to combine their unit test coverage and functional test coverage to get a total test suite coverage, which gives you an actual realistic picture of how much of your code is covered by tests. Because your functional tests will be testing stuff that you don't even realize is tested, which is interesting. Now, you can also integrate tools to help find gaps in coverage. This is usually done by things like mutation testing, tools that will go in and purposefully break code to make sure that unit tests start failing. And if it doesn't start failing unit tests when it breaks particular code, then it knows that that class is not properly tested. It's a pretty clear indicator. The other thing you need to look out for is tests that fail intermittently. It's kind of easy to just kind of brush them off and be like, whatever. But intermittent failing tests point to lots of other problems. I was working in a company once that had like a chunk of their functional tests that just wouldn't pass reliably. Like, no matter what they did, they just could not get reliable results out of it. And when we dug down into it, it turned out that in the environments that we had set up for running the tests, we had very small VMs configured to run 100 PHP processes. You could get about 6 cycles of the functional test suite done before they'd fall over. And so, just because a test fails doesn't always mean it's the code. Also, while you're testing, keep track of how long it takes to run these things. It's important. It'll show, if nothing else, a baseline trend of how the performance of your software is. The last really, really, really important piece is that when you have clouds, you start to have a decoupled sense of environments. And so at Mastery, we actually created a tool that you could give it a name and tell it how large of an environment you wanted. And it would go out to AWS and just create you a cluster of 13 or more servers. Multiple kinds of PHP workers, load balancers, database machines, masters and slaves, whole deal, whole 9 yards. You can make it single host of each copy, you could do 4 of each, didn't matter. But we had a whole bunch of test data that was stuck in specific environments, like our old staging system. And so we couldn't actually test these environments properly because we didn't have all of the data needed in order to execute our functional tests against the environments. Well, last I heard, they're still working on it. Now, what do system engineers want? I couldn't find a better name. This is ops. And I think systems engineers is kind of a weird name to them. It seems super generic. But then maybe a lot of other terms are too. So, what do they want? System engineers need clear guidelines for what their systems require. They need the servers to be treated as cattle, not special snowflakes. That means any changes you need to an environment or a system have to go through whatever system management tool they have. Don't go in and just install things willy-nilly. Go through the process because the process has value. Because the process means you can completely tear down an environment and bring it back up from scratch and not have to worry. It's just disposable. It doesn't matter. As much as servers can not matter, the better, because that makes them much easier to scale and much easier to manage. They need heartbeat systems and health endpoints, be able to tell whether whether software is up and down. It's important for DevOps to have at least a little touch on that so that you can actually disable hosts during release if you need to. You can go in and make the health check fail so that the host comes out of production and then you can deploy your code to it and bring it back in. Personally, I'm a bigger fan of immutable server architecture where you actually deploy it and create a container with the code and the server configuration and deploy that, and you never touch it again. If you want to put new code up, you create a new instance, put the code on it, swap them out. That way you never have to worry that the server got in a bad state. And if it does, because computers are computers, magically get in a bad state, your entire architecture is built around things being trivial. You spin up another one, replace it, who cares? And that all depends on the life cycle for your software deployment routine being fairly well documented, fairly clear. And have as little hard system dependencies as possible. We're moving into system-oriented architecture and building small services and things. And if you aren't pushing your developer teams to make sure that these pieces can move independently of each other, you're giving yourself a larger headache. And you as DevOps are able to contribute to the release process and say that these two things have to go together is a huge risk. Because it is. And so if you guys do the work to version your communication so that we can release new versions of either system independently, that will enable us to massively de-risk our release process. Because then we only have to release one component at a time. We don't have to risk the entire system being down because of a failed communication update. And the other thing is, with all this logging and everything that you're doing from your testing and all of you watching at the servers in general from deployments and everything, keep track of the metrics. Keep track of your server capacity needs and your requirements, and get them a notice when things start getting busy. Or set it up with auto-scaling architecture like Amazon has, and you don't even have to worry about that. We pretty much talked about all of this. I'm just going to go ahead and skip this slide. Building flexibility in a deployment system, and a lot of it's really DevOps I've seen has a lot more bandwidth to do things than Ops does, because Ops is dealing with the things that are making money, and DevOps is dealing with the things that are behind the scenes of the making of the money. If somebody in DevOps just stops responding for a week, things will probably be okay. You might miss, a release or something, but whatever's in production will continue running. If your ops department just leaves, you're going to be in pretty big trouble pretty quick. And the last bit was watch your performance stuff. Kick up notices or, auto-scaling architecture. Now, what do software engineers want? You don't want much. We want our errors to be caused by broken code, not broken environments. We want confidence in the test suite results and the automation surrounding them. We want to focus on the problem, not on the details around it. I call it tribal knowledge. It's the things that everybody in your organization knows, but nothing is ever written down. These things are bad. These things hurt developers daily. And the last thing they really want is to be able to have an independent place to develop their code so that they know they are the only ones affecting the state of the environment that they're executing their software in. Because if you have shared environments that aren't separated enough, you'll have side effects from one environment to the other. And you could spend half a day tracing down a bug that wasn't even actually in any of your code. And that really doesn't help anybody. And there's the general, what is everybody? You want to feel successful, right? At the end of the day, you want to go home, you want to feel like you did your job. With all this stuff that gets in the way, sometimes it can be pretty hard to actually feel like you did your job. You want to do the right thing. You want to know that when you encounter this problem, you solve it this way, and you know that's the right way to do it, and you don't have to worry about it. It's just how it's done. And so, what do developers actually need? And that's kind of a specific, kind of not a specific enough question to really answer. And so, I broke it out a little bit more. What do developers need to be successful? What do they need to be efficient? What do developers need to be happy? Well, remember we were talking about empathy, right? So, What do developers think about when they're writing code? We talk to ourselves in our head. No, maybe not everybody does, but I do, constantly. And then I talk out loud, and it's really annoying. Anyway, you know. So one of the things I think of is, especially when I don't have a good environment for knowing that my code is running well and everything, will my code even work? Because often we end up in situations where we have to tear apart the entire system in order to do one stupid little thing. And we won't know until we get everything back and realigned and just in perfect position if it's going to work. Good testing setups can help with this. I also think, will it break anything else? We see this constantly in legacy code bases that don't have good testing infrastructure in place. You have no way to reasonably scope out the impact of any change that you make. And if your error logging isn't correct and isn't done well, you might not even find out about it until it goes to production. Another thing I think is, gosh, these tests take a while to run. I had a company that put in their SVN pre-commit book that all of the unit tests had to be ran. And then they made a mandate that there needed to be 100% code coverage on any new code. But they didn't ever take any time to teach anybody how to write unit tests. So we had a lot of really large integration unit tests. It took a long time to run. So you'd run your SVN commit, and you'd go get a coffee. It's not really an effective way to write. Wow, this is taking forever. I hope it didn't break anything. You know, you come back from your coffee and it's still trying to commit the code. I wish I knew if my code works. And, you know, you test it, and you try the different scenarios you can think of, and you think you're pretty confident, and then you go hand it off to QA, and QA comes back, and I wish I knew if my code really works. And so now I'm thinking about it that I brought it down to the 3 C's that developers really, really need from DevOps in order to not only do their job, but do their job well and enjoy it. We need clarity, consistency, and communication. Those 3 things in place, everything else will fall in line. Now, when I talk about clarity, what I mean is they need to understand the environment that their code is running in. This means DevOps needs to work with operations to make sure that up-to-date information is available about the architecture that their code is deployed on. You need to know your different database clusters. You need to know where you have load balancers, where you have caches available, where you have memcache and Redis. You need to know the tools that are available in your tool belt in order to know the right tool to use for the job. Developers also need to know the capacity constraints of the current system. They need to know if things are already kind of bordering on the edge of falling apart, so that they don't go and add a load-intensive thing to the system without giving any heads up. Of course, when they go and add that high-intensive thing to the system that's already on the verge of being overloaded, they're going to need real easy access to those error logs. Most of the time, error logs just get dumped on the server that they were generated on, and you have to go spelunking through the servers to try and figure out which server the error hit and where it was and what went wrong. And then you have to try and debug it and get that message to that host again, and it's a giant pain. There's central error log systems out there. There's Splunk. There's Kibana. There's a couple others, I'm sure, as well. They'll sit on your servers, gather your logs, send them back to a central place, and then you essentially have Google for your error logs. Really interesting. And if you combine that with there's this command line tool called Spark, and you can actually create histogram chart graphs, like sparkline graphs and stuff, that you can put out over IRC or HipChat or anything like that. And so you can give queries to your system for how many PHP errors have I had in the last hour, and it will show you back a little graph. At Mastery, we integrated this as part of the release process to watch the error logs. And so we'd actually have a nice visual. We would see visually if we started generating more errors. Right in chat. We didn't have to sit in the tool to watch the logs. We didn't have to sit, on the server to watch the logs. The logs came to us because DevOps made it happen. And developers also need to know how to debug the other components that they're not responsible for. That information needs to be there. DevOps probably isn't the right team to make that information, but you're definitely the right team to push the requirements for it. You guys handle the handoff, the coordination between the organization. So when we talk about consistency, all the execution environments must be the same. As sane can be, they need to be the same. I have another talk where I talk specifically about the importance of this. But the easy way to sum it up is if you write your code on a local development environment, and it's good and you're happy with the functionality, and you push it out to QA, and they find a bug. If the bug is expressed using the exact same method that you tested, and the only difference is the environment, when you fix that bug in your code, you're actually breaking it more. And now you have two bugs to maintain, because you have the bug, and you have the bug which fixes the bug. On top of just the sheer problem of having to make sure the environments themselves are the same, all that data that goes along with it, that needs to be the same too. The company I used to work at actually built a process to make a snapshot of production nightly. And then in that snapshot, we would delete everything that was customer-centric and everything that was sensitive. And then that would become our new staging database. And the staging database was the basis for every other environment. So if you needed a particular piece of test information embedded into the system when we first made it, you could add that test environment to live, and it would just filter on down to the developers. Later on, we actually built a system that would allow you to upload custom SQL and configuration files to S3. And the deployment system would look in various S3 buckets for additional information to layer on top of the environment. And that's how we coordinated moving all of our test data completely out of the environment. We encapsulated the test data into the individual files so that all of the test data for a particular test case lived in one place. You could see the entire requirements for a test in one file. And the other big thing is automate everything you can. Really. If it's possible to be automated, do it. Because anything you do by hand, you will screw up. Eventually. You will make a mistake. Now, communication, this one's a little different. There's more rules. Don't make them wait for information you can tell them later. Like the whole, I'm committing to SVN and coming back in 20 minutes when it actually commits. Don't block me making more progress on my work simply because you're trying to verify something. Let me continue working while you verify in the background. But it has a kind of corollary that becomes a little bit of a problem and becomes a kind of balance. Because if it's been more than 15 minutes since I committed the code, I've probably gone on to something else. If it's been more than 30, I guarantee it. I'm not working on that thing anymore. You may as well not tell me. Or you need to find another way to tell me, because I'm not going to look at that email. I'm not going to action off of that email. So, to help with that, build a suite of, no, I use the agile term, passive information radiators. Really what that means is like wiki pages that are automatically updated from data in the background. Create central places where everybody knows to go to find status information. And make all of that status information share the same sort of visual language. Because that'll make the entire system very easy to consume and very easy to understand. If you have each page look a little bit different, then every time you go there you have to figure out which page you're looking at and what it means when this means that. It takes work away from being able to focus on the actual problem you're trying to solve. The other thing you can really help with on the developer side is helping them to communicate breaking changes across components. Because DevOps owns all of the testing infrastructure for automation. And so you guys see when the parts start moving. And so when you see that a new release of one component has been completed, start running integration tests with that component against the others. Make sure everything's still working, make sure nothing's broken, make sure there's no dependencies that nobody knew about. Because people are generally really bad at tracking subtle dependencies. And I have some lessons learned on top of this, which, you know, building tools for developers teaches you lots of things. The big one that hit me that I didn't even realize I had a problem with was I had a massive amount of fragmentation. And for those who don't know the term, it's the differences within a device class. And that was a real surprise to me because everybody at work was issued the exact same laptop with the exact same software built the exact same way. But did you know there's this environment parameter called CD path that if you set it, you can magically use CD to change directory to multitudes of different directories. It will look at a number of different places. And this wouldn't be notable except for the fact that it all of a sudden makes the CD command start outputting strings to standard output. Which if you have bash scripts written around, you know, controlling directories and making sure where you're at in the directory structure and making sure which execution context you're in, using the CD command to do things, all of a sudden you have users who can't do things. Who have entirely broken scripts and can't, like, load the local development environment. Which is, you know, not the greatest position to be in when your job is to run the local development environment. The best solution I had for that was to run a graphite instance, or static, and just have the tooling of the system, the tools that you build, send back information about the computers that it's running on. Give yourself visibility into the fragmentation that you have, so that you can make plans accordingly. Some developers will install custom Ruby, some developers will, you know, screw up all of their paths. They do amazing different things. And the hilarious thing is nobody has any idea that anybody does anything differently. We all do these things and we're like, everybody has to do it like this. We can't even fathom that nobody else knows about this thing that we do. Most of the things that we do that we think are really cool, nobody else knows about. The other big one is, unless you already have great communication inside your organization, they aren't going to tell you about bugs. They will sit there and try to fix things for half a day, 2 days, 3 days. And when they can't do it, they'll just stop using your tool. And they'll go back to doing it the old way, which is usually going to be by hand and usually by messing things up. I don't really have a fix or a suggestion for this. My last couple of days at Mastery, I emailed out that I would give people free money if they gave me feedback on the local development environment that I managed. This was to a group of 35 engineers. I had 4 responses. I put free money in the subject. I don't know.
Block the spam.
Spam block.
Right. I don't know. Intel, I don't think would trigger as spam. I know other people got the email because I got the 4 replies. But it's something to think about because you'll push software out and you'll push updates out and you'll not hear anything. You'll have a couple people who will come back and say, hey, great, that was awesome. But mostly they'll just be quiet. You have to chase your users. You have to ask them proactively how they like the tools and what you could do better and what could be working better for them because they won't just come and tell you. I don't know why. Maybe someday they'll figure it out. Meet your users on the turf. This one's a big one because the way I generally started building things was I would build a CLI tool because I sit with the command line open all day because I'm one of those weirdos who just uses Git and command line. I don't like the tools. I don't trust the GUI tools to do exactly what I want it to do. I use it by hand. And so I build command line tools. Fortunately, the other guy who was doing DevOps with me didn't have that love of command line tools. And so we ended up building a shared library which was split between a HipChat bot and the command line. And so either thing you could do in either place, but whichever the users preferred, they could use. The one further would be to make an actual desktop app for the people who just can't do it without the GUI. But if you pick your languages right, you can do it in one set of code for at least the base the base API. And what we actually did is we used Jenkins. We built Jenkins jobs for all the different things that we wanted to have an API for. Kind of like the poor man's API box, really. Because you can use a custom hash in Jenkins, and it will let anybody trigger a specific Jenkins job. So it's an interesting way to just kind of open up an ad hoc API. And the last thing is tribal knowledge is the enemy. It is really, really the enemy, and it's silent. Because you don't realize what you don't know until somebody tells it to you. And usually, what you do at that point is swear and go back to what you were trying to do in the first place. But the first thing you need to do when you uncover tribal knowledge is you need to go make a wiki page. Because then it's no longer tribal knowledge. You've broken the chain. Now, lastly, I have a couple of examples of tools that I have built for developers along the way. At Mastery, for my last year there, I spent it maintaining the local development environment that all the developers use to write their software. This is the footprint of that application. It started with just a couple of command line scripts, and it just kind of grew and grew and grew as I found more problems that the users were having and found ways to deal with them. And the interesting thing is, even when you look at this screen, it is still actually a giant cobbled mess of bash scripts. But I used Ruby in the option parser and this CLI tool called Thor. It's a library that helps you make command line tools in Ruby. And so I made a self-discovering command line tool where every single command was documented inside the tool. They could use help to describe all of the situations in which they would use any of the commands. And I put the knowledge of how to run the system in their hands instead of putting it in a wiki page or having to tell them directly or having to have them figure it out on their own. Give users the tools to do things easily. You'll notice in here, I also have local dev bug and local dev idea. This is to make it easy for people to submit bug tickets. or feature improvements. Running that would just execute a open command for a URL to our Jira issue tracker, which would automatically pull up a ticket template that was partially filled out, especially in the event of a build error. We would take all the errors from the system and just pre-populate the form. All they actually had to do in that case is hit submit. Make it easy to do the right thing, and people will do it all day long. The last trick I learned before I left was I automated getting the bug report in with a Jenkins job. Because sometimes people would just not hit that button. It was too much work. Tribal knowledge elimination examples. So, ops will usually come up with these long, complicated schemes for how they name hosts, because ops wants to codify all of their information about that host that's relevant to them in the host name. Only little pieces of this actually matter to the developers. PHP worker? Yeah, we need to know which sort of machine we're going to. PHP worker 01? I usually don't care which one I have. US West 2, I don't care where it is. Where the server lives doesn't matter. It's a server, it runs my code. Bug Smash, you just pick the name for an environment. We encapsulate it inside a piece of information. That would be actually kind of useful because that's like a specific environment. That could be, staging or dev or Jacob's VMs, And since I could never quite remember exactly what that string was that would magically get me to the server I wanted, Ops had a inventory system that they published their server information to. And so we had JSON blobs that we could then consume and actually break apart to discover the information about the hosts. And it was organized by environment, and then by host, and then by specific host within that class. And so I built a tool where I could just go farm, SSH, environment name, type of host, and optionally, if it mattered, which of those hosts I wanted in that class. Any of these things that you didn't add, it would ask you. Like if you just did farm SSH, it would say, you have these 35 environments. Which one do you want to go to? You pick it, and then it goes, this environment has these kind of hosts. Which ones do you want? You pick that. There's 5 of these hosts in this environment. Which one of those hosts do you want? And have sensible defaults where you can. Like which host you want out of the PHP workers? Default to 1. It doesn't actually matter. More than likely, they don't care. We'll give them the opportunity to just hit enter. Make it easy. Another example, I started a place and I had some Russian coworkers and some other foreign coworkers who had some really interesting last names. And the convention for creating code reviews was to put the username inside your commit message. I have terrible memory for names. I'll never remember how to spell that name, not in the first couple of days, and I'm trying to make my first commit. And after that, I'm going to make another one and another one. I don't want to have to remember all this stuff because it's actually not important. Who it goes to is important. What their name is, less so. Especially their username. And so I made a script that I put in place of the SVN editor. And so when I went to go commit, it would bring me to this interactive console and say, do you want to commit to review? Do you need a dependent? Who do you want it to go to? Pick by number. Always showing the same person for the same number. So it's very easy. It's muscle memory. Who gets what code review without having to worry about anything. And it gives you a drop and write your commit message as well. And then it takes all these pieces that you've told it and forms the actual correct commit message for what you're trying to accomplish and does your commit for you. There's little helpers to get along the way. The other thing I noticed is during my term at Mastery, we had this wonderful local development environment, and you'd go and you'd develop code on it for a while, and then you'd push it out, and then somewhere along the line, somebody started complaining about some errors. So what I did is I mapped all the error logs back to your machine. And then I wrote this little tool that sits in your system tray and watches that directory with a set of rules. And so whenever it sees any of these error logs that I've defined to move, it sends an OSX notification. When you click on it, it opens console to the error log in question. Making it easy to do the right thing, giving developers visibility into things that are broken, and clearly communicating problems. These are the things that DevOps can do for developers, for testers, for operations, to really, really make the organization run smoother. Last little bit, I work at Kickside. We do really neat mobile games and online games and solve lots of interesting problems. We're hiring if you like San Francisco. Thank you guys very much. I appreciate it. I love coming to talk, and I love seeing the community participation out of places like this. It's awesome. I was really excited when I got picked to come here. I've been at one other conference like this. That was Codepalooza last year, and it was just amazing. The amount of information that you have access to with so many tracks running is incredible. Thank you so much for coming. I appreciate it.